Good day everyone. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the 12th session of the Digital Business course. In this video, we are going to discuss about a couple of emerging digital businesses, which are mobile commerce and smart commerce. Mobile commerce was pioneered as a pure digital commerce. Back then, customers purchased digital content such as ringtones and wallpapers to customize their mobile phones. Mobile commerce refers to digital commerce through mobile devices. Some of the characteristics of mobile commerce are 1. Mobile, along with customers' mobility. 2. Very personal, since each customers own their own mobile devices and each of their mobile devices are personalized for themselves. Now let's look at how mobile commerce works. First, customers will input their transaction data through a mobile application or a mobile web browser. And then, the transaction data will be encrypted and transmitted through a mobile network. Afterwards, the data will be relayed through an internet backbone such as fiber optic. Then, the transaction data, which is still in the mobile form, will be converted into a web form so that it can be read by web servers by using middlewares, such as Wireless Application Protocol or WAP. Since the transaction data is now on the web form, then a web server or application server now can respond to the transaction data. The response will be dependent on the customer's initial transaction data. If the initial data is a login data, then the web server or application server will respond by authenticating the login data to the database. The response will be encrypted and translated as a mobile form so that it can be read by customers' mobile devices. Finally, customers who receive the transaction data will be able to read, listen, watch, or interact with the response. Next, we will look at the types of mobile commerce. Mobile commerce types can be divided based on the mobile attributes capabilities. The first one is based on business needs, and the second one is based on consumers' need. Employees of a business who needs to be in mobile, such as salesperson or marketing, needs to be connected to the company's database or conduct transactions, in which they can use their mobile devices to conduct these transactions, such as using mobile point-of-sale system. Businesses can also track their goods movements during the inbound logistics process, warehouse management process, and outbound logistics process. And there are many industries that can utilize this mobile commerce, such as hospitality industries, education industries, until the military. Let's look at an example of how a direct service delivery route accounting mobile commerce works.
Peppery's direct store delivery and route accounting module helps your drivers visit more customers, deliver more goods, and sell more per day. With Peppery, you can manage deliveries, payments, and van inventory. Monitor KPIs for improved sales and productivity. Take van sales orders with complex pricing calculations. And track competitor products and promotions for business intelligence. Here's how it works. At the start of the day, your driver arrives at the warehouse and uses the Peppery app to see which orders and inventory the sales manager assigned to him, which need to be loaded in the van. If required, the driver can clock in using the app and record the van's odometer reading. The app displays a list or map view of the driver's scheduled stops for that day. Tap the first destination to navigate there using your preferred navigation app. Once the goods have been delivered, payment can be collected. Peppery syncs seamlessly with ERP and payment systems. A digital or paper receipt can be given to customers. If the customer needs to return unsold items, the driver can also issue an RMA with Peppery. Returned items can automatically go back into the inventory if they are still resellable. Peppery enables drivers to also take orders on the spot from their van inventory or for future fulfillment, with all the customer-specific catalogs, price lists, and promotions in hand. Back at HQ, managers can track each driver's route and activity and send them updated tasks while viewing KPIs and analytics. The DSD and route accounting module is part of Peppery's enterprise sales platform. connecting all your B2B sales touchpoints so you can sell faster and smarter.
Meanwhile, consumers also have their mobile needs, such as mobile entertainment, like watching movies or listening to stream music. Most of the services that consumers need in their mobility are on-demand services. This includes on-demand entertainment, on-demand transportation, on-demand education, and on-demand healthcare. Consumers can consult with physicians using mobile applications, such as in Indonesia we have Hello Doc, and receive treatment on the go, including prescribed medicines. Most of you should have already used on-demand transportation using mobile applications such as Uber, Gojek, or Grab. And most of the on-demand mobile services are using location-based services. Even the on-demand entertainment services such as Netflix and Spotify are localized based on your location. How does location-based mobile services works? First, you need to have a GPS-enabled mobile device. The device will transmit your longitude and latitude data through a mobile network and then relay to the internet. The longitude and latitude data will be read by a web server or application server, and then using a model predictive control, it will predict your locations or the best route that you need. The server will transmit the prediction data to the content provider, which will respond with the service that you demanded, such as movies and music based on your location, and transportation services based on your location and routes that has been predicted. Mobile commerce on-demand services such as Netflix, Spotify, Uber, Gojek, or Hello Doc are using platform business model, which connect the consumers and the provider of the services. This is also called the mobile intermediaries. Next, let's look why digital businesses conduct mobile commerce. First, the rapid advancement of mobile technology foundations. For example, from LTE or 4G to 5G. Mobile computing devices are also becoming smaller, such as using tablets, smartphones, or wearables. These mobile technology foundations provide with more advanced mobile computing and ubiquitous computing capabilities, which then drives the need of mobile commerce applications, such as mobile commerce, location-based commerce, mobile enterprise, smart cars, and also home offices application. The ubiquitous capability and mobile application can be a business case opportunity for digital businesses through the utilizations of an appropriate digital business governance. Finally, we will discuss the mobile commerce challenges. The first challenge is the security and privacy challenges. As we have previously discussed, a characteristic of mobile commerce is personal. Mobile commerce applications will ask permission to read and utilize customers' private data that is stored in their mobile devices. For example, customers' location data. Most of these private data are very sensitive and thus have a lot of security consequences. Therefore, mobile encryption, firewalls, one-time passwords, second-level or third-level security systems has become a security standard for mobile commerce transactions. Privacy policies are updated regularly and became more transparent. The second challenge is the strategic management challenges. For example, the utilization of the bring your own devices policy or build your own application policy. While employees becoming more convenient because they can customize their own devices and applications, standardization of the mobile business process will become a major issue. Smart commerce refers to a digital commerce that has the capability of data analytics, thinking, and making decisions based on customers' profile, customer behavior, and other publicly available customers' personal data through the use of smart technologies. What are smart technologies? How can a technology be called smart? Smart technologies are technologies that can imitate or mimic the cognitive process of human. This technology emerged first in 1950s and is called the artificial intelligence. Historically, artificial intelligence is designed to imitate human cognitive processing in playing games, simulating the decision-making process of deciding the next move of the checkers game, backgammon, or chess. The decision-making process was designed with a what-if analysis. Although it can support complex decision-making process, the decision-making process is linear with decision branches. Artificial intelligence then evolved in the 80s with the innovation of artificial neural network. Artificial intelligence becomes smarter as it can read, understand, and learn patterns on data analytics. The cognitive process is becoming more complex, and human face can now be recognized as patterns of factors. This type of artificial intelligence is called the machine learning artificial intelligence, as it has the capabilities of learning patterns. Machine learning is becoming popular when in the late 90s, a computer-based machine learning system, Deep Blue from IBM, had a chess match with the Grandmaster of Chess Garry Kasparov. Kasparov won the first match in 1996, but Deep Blue made a comeback and won the second match in 1997. Finally, artificial intelligence evolved again in 2000s. It now has the capability of understanding and learning objects as a whole, not only as patterns, such as using a complex semantic analysis to recognize the sentiment or emotion of a paragraph, or recognizing human face using 3D facial recognition. This type of artificial intelligence is called the deep learning artificial intelligence. Artificial intelligence has a major flaw, since it cannot recognize emotions in the human decision-making process. Artificial intelligence do not have sympathy, empathy, or affection in their decision-making process. Let's look at an example of how artificial intelligence works in a smart commerce.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
See how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When? Today?
Next
Tonight?
Wednesday at 6 p.m.
Oh, actually we leave here for like after like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can count for 4 people, okay?
Oh, I gotcha. Thanks.
Yep. Bye-bye.
The next smart technology of smart commerce is the Internet of Things. Internet of Things has the capability of gathering customers' personal data or personal related data from around the customers, process it, and send back the data to customers or the technologies around the customer. Let us now look at an animation that shows how Internet of Things work.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom-built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
The next smart technology of smart commerce is the combination of both artificial intelligence and Internet of Things, which is the Intelligence Assistant. Intelligence Assistant has the capability of making decisions of customers' personal life. It can help manage customers' home, its utilities, and its home appliances. It can also make decisions on customers' personal finance, such as recommendation of time deposits, recommendations of stock investments, and it can also make customers' personal purchases such as purchasing of groceries. It can gather data from customers' smart refrigerator and look for groceries that is needed and purchase it online. Intelligent assistants can also conduct direct conversations with the customer.
Alexa, ask Educators Credit Union what's my checking balance?
The balance for your checking account is $826.46. Would you like this information sent to you?
No, thank you.
Intelligence assistants can also help customers in paying their bills. It can collect customers' electricity usage data from a smart meter and analyze customers' financial condition and initiate transactions based on customers' financial condition. For example, if customers have enough money on their banking account, it will initiate a direct debit transactions. However, if it's not, it will initiate a credit card payment transaction. Or it can initiate payment using peer-to-peer lending application. That is all that we can discuss in this session. For further details, we can discuss in our synchronized session. Thank you very much for your attention. Good day. Assalamualaikum warahmatullahi wabarakatuh.